Okay, it's recording now. So let's start. Let's start with Java, right? Let's get to know more about Java. So before we start with Java programming, right, we have to go back to the basics. Like, what is a computer? All those things. I think
Mm,
I'm not sure if you guys are gonna have like semester tests on that, but they usually, yeah, they do ask those questions. Since you guys are gonna have 3 semester tests, two are theory, one is practical. So
mm,
yeah, there's a lot of theory questions. Semester test one is theory, semester test two is coding, semester test three is theory. Then you have
theory.
exams. So yeah, so we need to actually cover most of the things. So let's
Mm.
start with, I think the textbook is started with
How
programming, right?
much do each thing-
Yeah.
I'm saying how much do each of them weigh?
If I'm not mistaken, it's like 30%, right? I think it's
Uh,
20,
but
25 to 30% each. And then the practicals like that 10%, including class tests. That's the
mm,
last 10%. You can easily get a top achiever this module. It's
plus
easy.
test.
I'm serious. I know people never liked the module, but they watched my recordings or my videos and then some managed to get 100 in like the coding, but even the theory, it's not that bad. Some they got managed to get 90 something.
Mm.
And it's interesting because you actually make apps whereby there's buttons this semester, next semester, I mean. So
Like what?
you make apps. You see
Mm,
here, you see that there's buttons I can click, whatever. You see, I
mm,
can say file and shows this. You can actually have they're gonna teach you this next DFS semester. You're gonna use a tool called or a framework called JavaFX,
mm,
which helps you to create buttons and all those things to make a GUI, like a graphical user interface.
mm.
Okay, so let's start. So, what is programming, right? That's where we're going to start. So, what's the big fuss about programming? So, programming, right, is basically the process of creating a program. You can say a program or software. Software is another term for it. So, they are used interchangeably, right? You can call it program or software. As you can see in the term, in the word programming, right? There's the word programming. I am making the program. Is the art or the process of me creating the program. That's what programming is all about. So, what is a program or software? The thing that we're making. What is that thing actually, right? So, a program or software is basically a set of instructions, instruct, instruct, English, instructions, that is a set of instructions that tell what the that tell the computer what to do, right? That's basically a software program. It's just a set of instructions that tell the computer what to do. For example, you look at your dog and you say, Bobby, bark, and then your dog barks, right? So in this case, would say that the program is the dog, is the animal, right? Because it's going to be given a set of instructions that it's going to do, which is the same thing as a program. So for example, this Notepad++, right? It's also a program or software. It's being created in such a way that when you click on file, it does something. You see, it shows you options. Someone wrote the code to say that whenever this button is clicked, show these options. Whenever you go to edit, show these options. When you go to search, show options or things that are related to searching. Not inside Notepad++. Someone wrote that programmatically, right? By programmatically, I just mean that they wrote it in terms of code, right? So this set of instructions, right? It's sometimes called this. the set of instructions are sometimes called code. We sometimes call it code, or what's the other term for it? Um, yeah, let's just stick with code. So this set of instructions are sometimes called code, right? So, oh yeah, it's either code or source code, right? One of these terms, in short, they can call it code, or in full, you can say source code. So that's those instructions are sometimes called source code. So when you see a developer, right, or a person who's making the software, and they say, can you show me your source code or your code? They mean show me the literal instructions that you wrote inside using that specific tool, whatever that programming tool is. So in order for us to achieve this thing, right, of making the program or software, we need something that is called programming tools. And these programming tools, for example, like a programming language, right? We need tools like those. So a programming language, right, is basically the tool or a language that we use that has specific keywords that we use to make the program. So that's basically what we're doing when we're doing programming. We are creating a software or an app. These days they call it apps, right? Like an app that does something. So for example, WhatsApp, it's a communication app, right? Or communications app. It's an app that is meant to facilitate communication from for you to be able to communicate with someone from from any distance or anywhere in the world, right? That's WhatsApp. Back in the days, you would have to write a letter and then go to the post office and then put a stamp on it, and then it gets approved, then it gets sent. It takes a week or so for the recipient to receive the message, then another week or so for the person to send back a response. So some developers out there, they're like, okay, this is not good. Let's create an app or software or program that will allow users is people who basically use the app. Those are the users. So it allows an app that will allow users to be able to communicate with one another instantly, right? And then apps like Instagram, WhatsApp, Twitter, or now formerly called X, those those apps were made for that sole purpose, communication. So let's go back into a bit of the history of computers, right? So that you can understand why programming languages are very important. So before we can understand programming, we need to have it's not necessary, right? This information is not necessary for you to be able to learn a language, but it helps you to understand what your code does. That's the most important thing in programming, so that you understand what your code does. So in programming, we have two set of things, right? Or the thing, how do I put it? The device that you're using to make these programs, right? It has a certain set of information or things that it has, right? So we need to have just a little bit of understanding of that device. So a computer, right? Remember remember the definition is that we tell the computer what to do. How will the computer know what to do? In order for us to understand how the computer will know what to do, we need to define a computer and get to know what a computer does. So a computer, I'm not really going to go into the definition of a computer, but a computer has two things. It has hardware, right, and software. So with these two things, right, they differ in this sense. Hardware is basically the physical components. I'm going to say physical. You can say physical or tangible, or you can say visible components. Another word for components, it's parts. So components or parts of the computer. That's what we call the hardware, right? you'll understand why I'm taking this so much time defining these things, because I need to it's sort of like a ladder, right? We climb, we take one step at a time. Eventually we'll get to the top. So it requires a bit of patience. So software, these are the non-physical, or I don't know if it's I don't know, non-tangible or intangible. I don't know what's the antonym of tangible, but or I can just say the non-visible components or parts. So these are the non-physical or non-physical or non-visible components or parts of the computer. So some of the examples of hardware, right? The hardware can be a CPU, hard disk. Those would be examples of hardware, right? Examples of hardware. This will be hard disks, and then we have CPU. That's also there. Memory. Then what else? Yeah, let's just use these examples. That's fine. So we have hard disks, CPU, memory, etc. Right? So this would be the examples of hardware, and then examples of software. Right? Remember, software is the non-physical part that we how do I put it? It's like it's not tangible. We can't touch it. So software, examples of software is basically, for example, Microsoft Word. Can you touch Microsoft Word? No, you can't. I think non-visible is not the right term, because you can see it, vision, you can see it. I guess I would have to rephrase this non-visible. Yeah, I can use non-visible. Yeah, in the for defining software, because you can see Microsoft Word, but you can't. It's not a physical thing. You can't touch it, but you can see it. So that's software. Can be Microsoft Word or code blocks, anything that's inside of a computer, right? So what is the purpose of all these things, right? The purpose of all these things, they have their own purpose, right? Remember, a computer needs to have all these components together in order for it to be able to work. Hardware on its own is basically useless. Why is it useless? Because if hardware was not there, if hardware was there and software was not there, that means we couldn't use the computer, because now we just be touching the physical parts. What's the point of using or touching the main memory or the hard disks and not being able to see what you're doing, what happens when you touch specific hardware components? So that's where software comes in, right? Software helps us, or software gives us, right, gives us a graphical user interface to help what tell, or to tell, let me not say help, to tell the computer to tell the computer to what's that word? It gives us a graphical user interface to tell the computer to interact, to tell the computer how to how to work, or how to finding it, I'm giving a bit of difficult phrasing it in such a way that it's going to be understandable. Basically, what software does, right? Remember what these physical components, right? It'll be very cumbersome or very tedious for us to work with them directly. So hence we have apps or software. That software interacts. I think the word that I'm looking for is interacts, on how to interact with the hardware. Tells the computer how to interact with the hardware, or how to use the hardware, right? Without having to, for me to take my hands and physically touch the components. That'll be hard. So hence we have software and hardware, and they're all intertwined, right? They work they work better together. One cannot work on its own. For example, if you have only software and there's no hardware, where are you going to run the software? If you have hardware and you don't have software, how are you going to see what your hardware is actually doing? So it becomes a problem. So hence they work hand in hand. Then I'm just going to cover, since we have an understanding of hardware and software, now we can go to, I think these three things are very important to understand. So let's start. I'll start random. Let's start with any of the three. So let's start with CPU. So CPU stands for Central Processing Unit, right? The Central Processing Unit is basically the brain of the computer. Since you have a brain, right? So that brain in a computer, we call that the CPU, or the Central Processing Unit. And then the Central Processing Unit has two components or two parts. It's like split into two. So we have the ALU and the CU, right? So what is ALU? ALU is arithmetic or logic unit. This is where anything related to arithmetic or logic. If you remember in calculus, they taught you logic. This is the part that handles that part, the arithmetic or the logic. That's supposed to be done in a computer. The ALU program handles that. And then we have the control unit. So the control unit, it just helps to control the actual parts. So for example, if you double click on a file to open it, it's going to the control unit is going to go somewhere in it's going to go to the hard disk, right? And then grab that program, which is control, right? Remember, it's meant for controlling things. So it's going to grab that program and then, or grab that file and then chooses the right app or software to open that file based on the file extension. If it's a .txt file, it's going to look for a default text editor that you have in your operating system. In my case, it would be Notepad++, or I have another one called text editor. So that means I would have to choose the program, but it knows which programs to open because of that file extension, and the control unit is the one that's handling that process. So that's pretty much the CPU. And then we have the hard disk, right? Hard disks can be anything. It can be, though I'll just list examples of what you know so far. It's SSD and the hard drive, right? Remember, SSD is just the solid state drive, which is faster than the hard drive, or you can go into those details later on. It's not necessary for. So what's the whole point of hard disk? So hard disk is basically what we call non-volatile memory, right? Non-volatile, by volatility just means that, does volatility just mainly asking the question, does the program delete the data when you switch off the computer? That's volatility. So when it's non-volatile, it means that even when you switch off the computer, the files are not deleted. Basically, that means it's stored permanently, right? So this means that you can use a hard drive to store data and programs permanently, permanently, right? You will understand why the hard disk is very important when we get to memory. So let's go to memory. So memory, or sometimes called RAM, or random access memory, is basically memory that is used. It is used by the operating system to load data and programs before running them, before running or executing them, before running them. right? Before you run the app, it gets loaded into memory. I think I should also call it main memory. That's another term for it, main memory. So main memory or RAM or random access memory, it is used by the operating system to load programs or data before running them or using them. Let me say before using them, right? So what do I mean? So for example, if I was to click on IntelliJ IDEA, right? I click this program, right? It's going to load. You see, behind the scenes, it's loading. You don't see what's happening, but what's happening is that the operating system, it took the file from the hard disk, which is where things are stored permanently, and then it loaded it into main memory. And then the control unit, the CPU, ran into it, took it from main memory and then ran it so that you can see it visually. There it is, I can see it. So that's pretty much the flow. Main memory, hard disk, and CPU, they're always working together. So main memory, in a way, you can view main memory as like the waiting area, right? And then when when you want things at the waiting area, the CPU goes to that waiting area. It uses the control unit to go fetch those things at the waiting area or at main memory from main memory, and then it shows them to you. It loads them, right? You can see them visually. So that's main memory. So main memory. So let me see what's next. So main memory. I think I should now explain a bit about what's there in main memory. So main memory, right? Like you said, you can load data and programs, right? Main memory is divided cells that into cells that are of byte size, right? They are of byte size. So by cells, you can view them as like, let me see if I can find that app while I'm trying to explain this. I think by cells, you can view them as like rows, sort of like rows, right? Yeah, just view them as like multiple rows. I think that's a good picture, but while I'm explaining that, let's wait for, yeah, while I'm explaining, hopefully this thing will finish downloading soon. So it's divided into cells that are of byte size, right? They are of 1 byte. So each cell or each row is 1 byte each. And each cell is assigned a unique memory address. So for those who did C++ or who have experience in C or C++, this is where, when you're handling pointers and whatnot, you are actually accessing the address of that specific cell from main memory. That's what you're doing the whole time. So that's basically what we're talking about when you say each cell is assigned a unique memory address. And then each cell, since it's assigned a unique memory address, it helps to sort of like not mix up things so that when you have data there, the computer knows, okay, I should go to that specific address to find the specific data. So, okay, the app is done. Okay, let me close this and just open it directly here. So let me show you like a visual of main memory or RAM, how it looks. So I'm gonna create a blank diagram and then there we go. So main memory usually looks like this, right? You can visualize it in this way. So I'm gonna have each cell. Remember, we said each cell is a byte, right? But before I do that, let me explain a bit what is a byte. A byte, right, is basically equivalent to what? To 8 bits. And then you might ask, what is bits? We're getting to that. Bits is just a shorthand for binary digits. You see, if I delete the letters from N up until I, the I just before T, I will be left with bits, which just means binary digits. So these binary digits, remember, bi means two. So what are these binary digits? It's basically 0 and 1. So a computer, right? It uses electrical pulses, right? It alternates. There's this thing called transistors, right? A computer uses what we call transistors, which is basically, in a sense, you can basically say these are like electrical switches, right? And these electrical switches basically represent two states, on and off. So we can, we, since a computer, right? Things like on and off, you can't really represent them in a computer. The way the programmers decided to represent on and off states in a computer is that they said on will be represented by the digit 1, and then off will be represented by the digit 0, meaning that there's no current, or there's no electrical pulse at that specific point in time. So with this combination of zeros and ones, when we have 8 bits of them, right? 8 bits basically means that it's going to be a sequence of these zeros and ones, and it's going to be 8 of them. So if I have one, this is now 4, 6, 8. So this is what we call 8 bits, because there's 8 of them. There's 8 bits. There's 8 binary digits. There's basically 8 zeros and ones. And then this 8 bits, you can abbreviate it to 1 byte. The equivalent to 1 byte. So now you might ask yourself, how then can we represent information in a computer? How am I able to read? Oh, this is main memory. How am I able to read that if the computer uses electrical pulses? It alternates between electrical pulses, which is zeros and ones, on and off switches. How then can I represent data? So to represent data, right, we translate these ones and zeros into, we basically use something called an encoding scheme, right? An encoding scheme basically means that each letter is assigned a specific number. So for example, if I'm not mistaken, 65 is the capital letter A. Yeah, it's 65. And then 97 is small letter A, if I'm not mistaken. Yeah. So some group of engineers sat down and decided to come up with a table to represent, it's called an encoding scheme, to represent, to basically to assign a digit for each letter. And then obviously, if you can assign a digit to a letter, that means multiple letters like this basically translate to numbers. So I can have, so if 65 is A, 66 will be B, and then 67 would be C. Hopefully I'm right. I hope I didn't swap them around. 68 is D. So let's say you wanted to spell dead, right? Dead would basically, in a computer, the way the computer would interpret this is that it gets translated to numbers, actual integers. So what is the value of D? It's 68. What is the value of A? It's 65. What is the value of D again? It's 68. 68. And then now there's integers. Each integer, 68 gets translated to bits, and then 65 gets translated to bits also, and then 68 gets translated to bits. So at the end of the day, we end up having a sequence of ones and zeros like this. As you can see, this sequence of ones and zeros, they are hard to work with directly. That's why there's conventions or ways to avoid working with them directly. So this would, in a way, this is not the actual representation of this number. It's not the actual number, but you can picture it in this sense. So that's pretty much a bit about the computer, right? So we were talking about the RAM, right? And how the RAM is represented. So the RAM is represented by cells, right? And in each cell is 1 byte, right? Each cell. Each cell contains a data or an actual program. By program, I mean the actual application. This can be code blocks, this can be Microsoft Word. So when you click that Microsoft Word, what the computer does, right? It takes Microsoft Word, it puts it inside RAM like this, right? So let's say it's called my word.exe. It puts it inside a cell, it chooses any cell, right? Since remember these cells, they can be accessed in any order. Hence they are called, hence another name for main memory or memory is called random access memory, since they can be accessed in any order. So I can store a program which is word.exe. Remember in Windows word.exe, it's an executable file, right? That's how you find an app. It ends in .exe. On other application, on other operating system is different. DMG for Microsoft, for not Microsoft, for Mac OS, MacBooks, right? It ends in DMG. For Linux, it's .out. So it differs on the specific operating system. So this is how the main memory would look like. It would load the program in there. And then remember, each cell is of size 1 byte. So if we need to represent something bigger, we would have to use consecutive cells. So if I want to represent something bigger, I would have to take this cell. If it's not big enough to fit inside the cell, I have to borrow the next cell and use both of them at the same time. Because that number or that thing that I'm trying to represent is it's not it cannot fit in one cell or in one memory cell. You can call it a cell or a memory cell. So like remember what I said, each cell has a address. So the address is usually in hexadecimal. So I'm going to just do this, and then there we go. And then I'm gonna put an address again here, and then an address again here. Remember, the addresses are going to be unique for each cell. I'm just too lazy to come up with unique addresses. I'm just gonna copy and paste the same address, but just know that the addresses are going to be different for each cell. So we have this address, right? And then remember what I said, it doesn't actually load it as word.exe. It's going to be a sequence of zeros and ones inside that cell, but that sequence of zeros and ones represent word.exe, represent that program. You do not have to worry about that. The operating system handles all of that. You just need to have a deep understanding of what's going on under the scene or under the hood. So, okay, let me paste this. So this is what happens, right? So let's say I store, remember I was talking about this digit 65, whatever. So let's say you wanted to store the character A inside the first cell. And let's assume that character A is a sequence of these ones and zeros. So what happens, the computer will store this sequence of ones and zeros, but then when you read them, right, they get passed into, for example, a program like Notepad++, and they go into a process of translation. So you end up seeing the letter A. So okay, let me delete that. So let me copy this, and then I'm gonna put this side so that you can see what goes under the hood. So like I said, what's going to happen is that it's going to go through translation, and then instead of you reading these ones and zeros inside the cell, you view it as the letter A. Hence, when I open Notepad++, I'm not seeing a sequence of zeros and ones. The computer is handling that translation for me. So as you can see that the computer is pretty much a stubborn device, or it's something that's very stubborn. It can only speak its native language, right? By native language, we mean that it's like its mother tongue, right? So its mother tongue, what could its mother tongue be? Its mother tongue is basically a sequence of ones and zeros that I've been explaining so far, which represents two states, on and off. One meaning that it's on, and then zero meaning that it's off. So that's pretty much the language of the computer. So the machine's native language is bits, right? It's binary digits, basically ones and zeros. That's the language of the computer. So you might ask yourself, if that's the language of the computer, how was life before we had all this advancement, right? Remember that things were not the same as they are right now. So back in the days, right, developers would developers would write programs, or let me not say programs, would write instructions using the machine's native language. You can imagine how much of a drag that was. They would write literally in zeros and ones. So let's say let's say you wanted to add two numbers, right? So let's say you wanted to write a program that adds 3 and 5, right? You wanted to write a program that adds 3 and 5. So you'd have to know three things, right? So three things, meaning 3 plus 5. You need to translate three to ones and zeros, and translate the plus operator to ones and zeros, and then translate 5 to ones and zeros. You can imagine how hard that was to write. So let's say the program would be, let's assume this would be 3. This will represent 3, right? And then this will be 5. So if I wanted to add, let's say, let me come up with a different number. So let me put 1 here. So let's say this represented the plus operator, right? So let me not use equals. Let me do this. So that represented the plus, and then this represented 3, and then this represented 5. So if you want to say 3 plus 5, that means I'll take this set of numbers, ones and zeros, and then I'll take that symbol, translate it to ones and zeros, and then put it here. So this would mean 3 plus, this is plus, right? And then plus 5. And then this would be a sequence of ones and zeros, which actually translates to just 3 plus 5. And then developers saw that, okay, the computer's native language is very hard. As you can see, imagine this is just a small line of zeros and ones. Imagine if you have a very big programs. These days programs can go up to 13,000 lines of code. So imagine translating every single character, letter to zeros. It's going to be very tedious. You're bound to make mistakes. So therefore, they developed a language, right? This, remember, we talked about programming tools. They developed a programming language which was called assembly. The assembly language. The assembly language, it used it. You see, the only difference is assembly with assembly, right? It's still very very similar. It's like very similar to the machine's language or the native language. The only difference is that it used keywords, or sort of like short words. It used short keywords, or used words or short words to represent something, right? So what do I mean? So for example, if you wanted to add 3 plus 5, there was okay, those short things were called mnemonics, right? Those short keywords. And these mnemonics were mnemonics. They were like, for example, add meaning to add, and then sub meaning to subtract, then mul meaning to multiply, things like that, right? So it became, programming evolved. It became a bit simpler in compared to writing the native language, which is zeros and ones. So let's say, for example, I wanted to write add 3 plus 5. I'll just basically say add 3 comma 5. I'll basically write that. I'll say add 3. So basically this will just translate to take 3 and then add 5 to 3, which is basically 3 plus 5. So this was a bit better compared to writing ones and zeros, but there was still a problem. each computer, or let me just say each operating system, it has its own native language. That's the problem. So that means I would have to understand that operating system. Just to output hello world, I would have to understand all of these terms. You see from the top, and trust me, there's way more. I would have to understand what a CPU is, how it works, how it looks, even the diagrams. I would have to understand them by head, hard disk. I would have to know what RAM is. I would have to understand all of these things just to output hello world inside assembly. That was the problem. And that didn't that it didn't last for too long. So that's when they realized, oh, we need to expand on this. So assembly is not the stopping point. We need to continue, like improve assembly or find a way to make it better. That's when they developed higher level languages. And by the way, another term for assembly language is called a low level language. By low level, they mean that it's close or it's exactly the same as the machine's native language. Higher level language, what it does, it abstracts away from those low level details like the ones and zeros. You don't have to think about it. It handles that for you behind the scenes. So that's when higher level languages were developed. Right, these higher level languages, namely, were C, C++, Ada, which was named after Ada Lovelace, and then COBOL, which is mainly for making business-oriented application. It stands for common what? Common something, but it stands for business-oriented language. That's what I remember. And then Fortran, which is basically in full, it's just formula translation. So it's mainly for scientists and mathematicians. That's Fortran. It was developed for that purpose. So as you can see, most of these languages were developed for a specific purpose, right? C was made to just to still have the power of assembly, but to be user friendly. That was C's main role. And then C ended up being a very powerful language, and all of these other languages, they grew or they came from C, because C++, uh, funny, funny example, this was a funny way of naming C++. Remember, plus plus is to increment by one, so that means they added something to C, and that one thing that they added was OOP, which is object oriented programming, to C. So that's C++. It basically took C and then added one thing, which is object oriented programming, because that was the thing that was growing at a specific point in time. Languages were using OOP, but C was still stubborn. It was saying no. The authors were like, no, C is meant for building operating systems, so we can't put OOP. Then um, someone named Björn Strostrup developed C++, basically C with classes. So that's pretty much the high level languages that are. There's many more. You can research more on that. What we're going to focus on is Java, right? So Java, um, so I'm just going to, I don't have to go through all the other details. I think I've covered enough, I've explained enough. So I'm just going to go straight into Java. So Java, what was Java's main purpose? So Java, in back in the days, Java was actually developed as its main purpose to was developed to make internet applications, right? Any applications that were related to the internet, servers and things like that. That was Java's main purpose when it was created. And then it evolved, and then they had different editions, whatever. You can expand, you can make websites, things like that, but its main purpose was to make internet applications. So that was Java's main purpose, and then it grew, and then it evolved. So what's the difference between Java and all the other languages? So Java was made to be, it's robust. Java is also secure in terms of security. Java is object oriented, meaning that everything is it takes it views everything as sort of like an object, like in our just like in our real world. When you sit on a chair, you are sitting on an object, right? So it took that philosophy that objects are always interacting with other objects. So you are a person who's sitting on a chair, you are an object, and the chair is an object. You guys are interacting, right? So those are two objects that are interacting with each other. So that was the design philosophy of Java. So it was meant to be like that. And then it also has this thing called WARA, right? Which means write once and run anywhere, right? And it also has portability. It's portable, meaning that it can run on many operating systems, which can sort of like intertwine these two statements because it's pretty much the same thing. And then it another word for it, you can say it's platform independent, right? Meaning that it doesn't depend on a specific platform. So how does Java achieve all of these things to be able to like not to be able to not be dependent on a specific platform? So by dependent on a specific platform, it means that if I write Java and compile it and I try to run it in another operating system, I don't need to compile it again, or I don't need to code for that operating system. No, I just run it. That's it. So that's basically its philosophy. Write once and run it anywhere. Even the Mars rover, it was programmed using Java. That rover that went to Mars, that when yeah, for those science geeks, for those geeks out there, it was made using Java. So Java, as you can see, it's very flexible. It's not a bad language. Personally, I don't like it, but yeah, it's not it's a powerful language, right? We can all agree that it's a powerful language. It utilizes something called JVM. JVM just basically stands for Java Virtual Machine, right? That's what it stands for. So why why am I talking about Java Virtual Machine? What's Java Virtual Machine? What is it all about? As you can see, the word is sort of like self-explanatory in a way. Virtual meaning that it's not local, right? Meaning that it's like a virtual device. So if it's a virtual machine, that's basically how it achieves platform independence. That's how you're able to write code once in Java and then run it anyway. Because what happens is that when you translate Java code, it's not translated into that specific operating system's native language, right? Into that specific operating system's ones and zeros. No, it's not translated like that. It gets translated into it's sort of like an intermediary, right? So let's explain the process, right? So with assembly, you use something called an assembler, which basically translates the assembly from remember that like I said, the computer is stubborn. It can only speak its native language. Imagine you meet someone who can only speak French or Cantonese or Mandarin or Zulu or Afrikaans. The person can only speak that language. There's no other language that they can speak. That means a translator is required. So for assembly, the translator is called an assembler, right? So that example that I had before. So if you had 3 plus 5, the assembler would translate, it would translate it the specific, to the specific, to the specific operating system's native language. I hope you understand the terminology there. To the specific operating system's native language. That means if I'm using Linux, right, it uses the Linux kernel. So let's say I only speak Cantonese. That means it will be translated to Cantonese, right? Because that's where I'm currently compiling my assembly on Linux. And then if I translate it on Windows, it gets translated to Zulu. So you get what I'm saying? It's different for each operating system. That was the problem with a lot of languages. It's still also a problem till this day with all the other languages. But like I said, there's no perfect programming languages. There's no perfect programming language. You just some languages work best in certain situations. Some don't work in certain situations. You just choose what's right for you. So that's the problem with an assembler, right? Number one, you'd have to understand the hardware, meaning the physical components of the computer, and the operating system, and the mnemonics, right? You remember like I said, each operating system has its own philosophy, its own way of doing things. So you'd have to understand that way of doing things before you can code for that specific platform, which was a problem. So Java removes all of those unnecessary things, right? So Java or higher level language, not all, specifically Java. So when you go to Java, I'm not going to talk about C++ or whatever. We're specifically talking about Java here. So Java, it uses a JVM, which is a Java Virtual Machine. So that means what that means, right? It means that it doesn't translate it to a specific operating system. What do I mean by that? So remember, what in order for something to be run, it needs to be made as an executable. So when you use an assembler and you translate, it should generate an executable that is zeros and ones. But executable is basically I mean something that you can double click and it opens. That's what an executable means. So if you're on Windows, right, that's the problem with assembly. You have to know the assembly for that specific operating system. The executable will be .exe. If you're on Mac OS, it will be dmg. And then if you're on Linux, it will be dot out. As you can see, that means if I want to write code, I have to write it 3 times. That means I have to go learn about Windows, go learn about macOS, go learn about Linux, and then develop an app for that specific platform, and then it generates that specific executable. You see that it's even maintaining, it's going to be very expensive to maintain all of 3 different versions. That means you need to hire specialized developers for each operating system and multiple of them, which is very problematic. So instead, what the Java Virtual Machine does, right? It doesn't translate it to that specific operating system's executable. It creates sort of like an intermediary, right? So in Java, right, to create a program that adds something, I would say it'll be like this. It goes to 3 plus 5, and then semicolon. And then that gets translated by something that we call a compiler. The compiler, it basically takes everything in the file, it translates it all at once, and then gives you an executable. So what happens is that with Java, it uses a Java virtual machine. So virtual meaning that it's non-physical. That means it won't end in a .exe or a .dmg or a .out. It will end in .class, meaning that you see that it's independent of the platform. Hence, it's called platform. Hence, the author said that it is something called platform independence. It's not dependent on the specific platform. Then, what you do is on each operating system, right? On Windows, you need to install the Java Virtual Machine. Then you run the .class file, and then in a way, right? We don't have to go into the details, like the deep underlying details, but in a way, just think of it under the hood, it's going to translate it to that specific executable, right, for that specific platform. Under the hood, just view it like that. So this will be .class, and then this will be .dmg, and then Linux, this will be .out. So you see that with Java, we avoid this thing of writing three applications. I write one application, and then on the other operating systems, I install the Java virtual machine because that's the one that's able to run this .class file. And then that Java virtual machine, it handles everything for each specific operating system. If I'm running this .class file on a Windows, it will generate a .exe and then run that file. If I'm running on a Mac OS, it will translate that .class file to a .dmg. So as you can see that I write with Java, I write once and then I compile it. I write it once and then I run it anyway. Hence, it has this thing called WARA philosophy, which is write once and run anyway. And then that's pretty much Java, right? That's all you have to know about Java. And for those who are interested, Java, the name Java is a, what's that word? It's a slang for coffee, right? If you look at the Java logo, it's actually a cup of coffee. So keep that in mind. And Java was developed by James Gosling. You can research the author and find more about Java, what was in his mind. You can also see interviews if you're interested. You can go check them out on YouTube, all of those platforms. Even on Twitter, you can find all the details that you need. So it was developed by James Gosling, and it was, yeah, by James Gosling, right? And it was owned by Sun Microsystems, right? It's a company called Sun Microsystems, which got purchased by Oracle. So now Java is owned by the company called Oracle. So even when you download the tools that you need to run Java, you see that we're gonna go to the Oracle website. There's gonna be Oracle. So that's because that's the company that now owns Java. So there's quite a lot of information to take in. I know it's quite a lot, but yeah, it's information that needs to be taken in. You have no choice. You have to understand everything that's going on. So since we understand a bit about Java, let's talk about the last thing that we're going to talk about. You can research more, but then there's the last thing we're going to talk about is, or the last two things, we're going to talk about JDK and JRE, right? So the JDK is basically is the Java development kit. It's basically a set of tools that you can use to develop Java programs. It's like a kit. It's like, for example, a toolbox. It's like I'm giving you the toolbox. So the JDK, right, or yeah, the JDK or the Java development kit, it comes with the JRE. And what is the JRE? It's the Java Runtime Environment, which allows us to run Java programs. So you can install it separately, it's up to you. You can download the JDK, which is the full thing, the full package, and you can download the Java runtime environment separately. That's up to you. But we usually want the full kit. So that's what you're gonna install. And then lastly, we can there's it's called Java editions, right? So there's different Java editions. There's the Java. Okay, now I'm starting to forget the editions. We have I forgot the other ones. Hopefully I can remember. There's the Java Enterprise edition, and then there's the Java Micro edition. The Micro edition is used to make mobile apps, right, or mobile devices. That's what it's used for. And then the Java Enterprise edition, it's used to make web servers, right? If you want to make web servers, you have to download the Enterprise edition. And then I almost forgot the Java Standard edition, right? And they're gonna ask you these questions, so you better know them. You have no choice. They like asking about editions and things like that. Or they can give you an example. They say what edition will be applicable in this scenario if you want to make this app. So this one is used to make to make client applications, right? By client applications, for example, desktop applications. If you're making desktop applications, you can download the Java standard edition. So if you want to make web servers, enterprise edition, if you want to make mobile apps, or to make mobile applications, not devices, applications. To make mobile applications, you need to install the Java Micro edition. So these are all the different editions. We now know a bit about Java, a bit of its history. You can research more to learn about Java, but that's pretty much Java. So I think this should suffice. I think I should now show you how to set up your IDE, right? Remember, IDE just stands for Integrated Development Environment. So by integrated development environment, it means that it's integrated. It means that it has a lot of things. It has the Java compiler, it has the Java runtime environment to run Java programs. It has the debugger to debug, to look for bugs in your code. By bugs, it's just errors. We're just talking about errors. Fun fact, the first program that had errors, it had a bug in it. And then when they removed the bug, it started working. So hence the term debug. So that's why programmers now, they say, when you're fixing the program, when you're removing errors or fixing the errors, we call that process debugging. Debugging. Because there was the first program that crashed, it had a bug in it, and then they removed it, and then it started working. So let's download the integrated development environment, right? But before we do that, we need to download the Java development kit, which is the JDK, right? Because we can have the IDE, but how are we going to run programs when it didn't install the full kit, or we don't have the toolbox? Remember, we need tools, specific tools to solve specific problems. So for example, if you want to remove a tire, you go to toolbox and you look for specific tools. But how will the IDE know which tools to look for when you don't even have the toolbox? So we need to install the toolbox, which is the JDK. So I'm going to say Java JDK download, and then it's going to load. And then remember, we talked about Oracle, the company Oracle. It's the one that now owns Java, right? So I'm going to go to click on Java downloads. You can do it in whatever way you want to do it. You can, for UJ students, you can go to that URL. So I'm going to show you two ways, but I don't advise going to that URL, but it's fine. We're going to go there because it tends to be very complicated to set it up that way. I like this way. Things get done automatically for you. So when you come here, right, you're going to see this is the landing page. Java downloads. As you can see, the company Oracle is the one that owns Java. So the current Java version is JDK 23, is the latest release. But then we want Java 21, which is the latest long-term support, LTS. You might ask yourself, what's the difference? The difference is that the long-term support, most of the things that are there, they're not going to change them. So there's not going to be major updates. But with the latest release, things can change entirely. So that means if you wrote code using the latest release and things change entirely, that means your whole code base or the source code is going to crash. So we do not want that. We want the latest stable. This long-term support is the one that's stable. Most of the things that are there are finalized. That's what it means. So you're going to click to JDK 21 on this option here, click on JDK 21. And then depending on your specific operating system, you're gonna download the specific file. So I'm running Linux. I'm using Fedora. I'll choose Linux and I'll choose the RPM package because I'm running Fedora, and I know that if I'm using the Fedora operating system, the files end in a .rpm. And then I have macOS. For those using macOS, you have to download this one, the .dmg file. The other ones you have to extract. That's a process. We don't want that. So for the macOS people, right? They know themselves. There's macOS that comes with the ARM processor. ARM is like your ARM. That's how they named the processor. You can choose the ARM64 DMG installer if you have the ARM processor. If you have the Intel processor, you're gonna choose the X64 DMG installer. Only macOS people should worry about this. They know themselves. And then Windows, if you're a Windows, straightforward, you're going to choose the X64 installer. So for Windows, yeah, it's going to be tricky. I advise you get a laptop that's 64-bit, right? That because when you see X64, it means that it only supports 64-bit systems. If you have a 32-bit system, I think it's gonna work, but I don't. You shouldn't take chances and think it's gonna work. So eh, when the developers develop something and they tell you that it's x64, that means its target it's x64. So I advise
Well,
you get I advise you get a new laptop if it shows 64. To get more information about your operating system, right? For Windows, right? Most people use Windows. So for Windows, click the Windows icon, right? Windows icon, right? It should show you the search bar. And then when it shows you the search bar, you're going to, okay, this is step one. Click on the Windows icon on your keyboard. And then step two, in the search bar, you're going to type about. I think it's about your PC in full, or you can just type about. And then when you just see an option there and then press enter. And then amongst that, all that information that's there, you're going to look for X32 or X64. There should be information there. If it says X32, yeah, you might have a problem because here there's no X32 installer here. It might work. I've never seen anyone complain, but just to be on the safe side, you should make sure that it says X64. And then you're going to choose this executable one. The zipped one, or you can, okay, for Windows 11 you can choose the MSI. Okay, it doesn't really matter. Windows 10, Windows 11, you can choose either MSI.MSI1 or the .exe. I don't know why they did that, but they still both work on both operating systems. So you choose any installer that you want. You click it and then you just click on, and then once it's done downloading, you just double click on it and you keep on pressing next until you reach until it says installing, and then when it's done, you're just gonna close, and then done. You've installed Java, the JDK. That's all
so
you have
which
to
one
do.
do I download? Do I download the one you highlighted? Which one?
You can choose either. Remember, I said it's either the Windows. I don't know why Windows did that, but either works. If it's .exe, it works. .msi, it still works. You choose the one that you feel like choosing. And then let me see. I already have Java. Okay, the operating system that I downloaded, it came with Java. That's the luxury of some using some Linux operating systems. It came with Java. I didn't have to worry about anything. But if I wanted to install, for those using Linux, Linux is a very powerful operating system in the software engineering field or IT field. Even in the workplace, you need to know Linux. It's a must. So I advise you get familiar with it. You can use a you can install a virtual what thing and then run it that way, or you can install it directly. It's up to you. Or you can do something called dual boot. That's up to you. So once you're done installing, right, you're gonna open the terminal, and then in the terminal you're just gonna type Java hyphen version to see whether Java is indeed installed. And you see in my case, it came pre-installed. It was already installed. In your case, it should say LTS somewhere. You should have an LTS. For me, it's already installed. This is the latest one, JDK 21, the latest long-term support, the latest LTS version. So I'm sorted. I have my Java installed. Or for those do using Linux, you can download the file and then double click on it, and then it's going to open software. It's going to open your software manager. There it is. There's mine. And then just going to click install, and then it installs it. For me, it's already installed, so there's no point in installing it. And remember, we talked about editions. You see, this is the standard edition, JDK, right? The standard edition, because we want to make desktop applications. And yeah, you'll see that you're going to make desktop applications, GUI, and things like that. As you can see, remember what I talked about the JDK. It comes with the runtime environment, the JVM, the what development tools, compilers, debuggers. It comes with the full. It's like the whole toolbox. That's why we download the JDK, because we want the full set of the tools that we're going to use to write Java programs. Or if you wanted to, for this is for Linux users. You can open the terminal by typing Control Alt T. Linux users know, and then you're gonna move into the downloads folder, and then you're gonna find the file depending on your distribution, right? I'm using Fedora, so I'm just gonna say sudo dnf install followed by the file. So I don't think, okay, it's not executable. Yeah, and then you just say /g/jdk, and then you install it, right, like this, and then you press enter, and then it installs. If you're on Ubuntu, right, or Debian based, it's sudo apt install. It's pretty similar. It just the difference is the package manage. You're gonna say sudo apt install /jdk, and then just press tab. It's gonna autocomplete, and then press enter, and then it's gonna install the JDK. Or you can just double click on the JDK. Either way works. Remember, if you're on Debian, right, Debian based, you're gonna install the .deb file. Download the .deb file, and then double click on it, and then it should set up everything. And then now we're going to go to the eve.uj.ac.za/resources/CSC. CSC stands for ComSci. So this is where you're gonna find all the resources for computer science for UJ students. So if you wanted to download Notepad++, you can just click on here and it's gonna redirect you. Or Dear for making for ComSci 2, you don't need Dear. Yeah. You can use it because they said it's for any year of study, but you're not gonna need it. There's no UML or things like that. You just submit your prac and then that's it. So if you wanted to, right, you see there's the JDK here. You can download the JDK here, right? And then you see why I don't like this approach, because you need to understand what you're doing before you go to this website. You'd have to click somewhere here, the Java SE. SE stands for Standard Edition. And then you click here on Java SE, right here on this left panel. And then you look for the file. I'm not sure where you download the file. That's why I don't like this approach. It also confuses me. Don't don't install it this way. Install it the way that I showed you. And then okay, JavaFX, that will come later. We'll set that up later during the course. So I see there's Eclipse 2023-12, and please, and I'm gonna keep begging you again, please install the version that they showed you, because somehow Eclipse, if you're running a latest version and your lecturer was using this older version, it's gonna crash. That's just Eclipse for you. You need to download the version that they told you to download. It's 2023-12. That's the version that you're supposed to download. So you can just right click on the link there and say open link in a new tab. And then you're just gonna open the link in a new tab. And then I don't know, I guess because of the thunder and the rain, now all of a sudden the Wi-Fi is a bit slow. Or you could just search it and say download Eclipse. Just make sure you see the version that they're looking for. And then you go to Eclipse Foundation, the first link. Yeah, it's definitely going to be the first link. So you just click the first link and then it's going to open. Okay, it already opened. That's fine. Or you can just do it that way. So this is let me decline. I don't want cookies. So there's the URL, right? The website. As you can see, this package includes a Git integration. Git, for those majoring in ComSci, you learn Git final year. That doesn't concern you. The main thing you should be concerned about is Eclipse Java development tools. That's something you can be concerned about. Even Maven, you don't have to worry about that. You're gonna worry about that in the industry, not now. So now you need to choose the right package for your operating system. On Windows, like you see, there's a lot of 64-bit here. There's no 32-bit. That's why I'm very concerned if you're using a 32-bit. As you can see, when it says x86 underscore 64, the 64 means that it's 64-bit. It's targeted for a 64-bit operating system. And then this one is x86 again 64-bit for Mac OS. So this will be the Intel chips, and then this will be for um what's the other one? For ARM chips. And then Linux, same thing. I have Intel chip and or an AMD chip. You typically going to choose this section here if you're on Linux, right? Only on Linux. And then for Windows, you just basically click here and then it should download. I think it should start downloading. Yeah. So there it is. It's going to start downloading. But I don't like how you see, that's why I don't like how they show you how to download these things. I don't like it, to be honest. It's going to download a zip file, then you have to unzip, then you see it's a process. It's just going to confuse you. So the way I'm going to do it is I'm going to say download Eclipse. I'm going to go straight to my browser and download. The only thing that's important is for me to note what version is expected. I need to install the 2023-12 version. The latest one is 2024-09. Do not make that mistake. I'm telling you, your practicals are not going to run. It's going to crash. It's not even going to run. That's a zero. For all your assignments, you're going to keep getting zeros. Do not install a version they didn't tell you to install. Install the one that's being shown on that URL, eve.uj.ac.za/resources/CSC under ComSci 2. That's for second year ComSci. So there's the Eclipse website, right? I don't like how they do their things, but this is the way I would approach it. So there's the website. You can scroll down to learn more about Eclipse, all of that. There's also different IDEs. You don't have to worry about that. We are looking for Eclipse. So there's Eclipse, right? There's the logo for Eclipse. So I'm gonna click download here, and then I need to choose based on my specific processor architecture. I'm using 64-bit and it's an Intel chip. I'm not using ARM chip, so I'm gonna choose this first link. Or if you wanted to download different versions, you can click on download packages, right? So I'm going to click on download packages, and then under download packages, right? You can scroll down under the more downloads section. That's why I prefer this way so that you can see how to maneuver your way under this website. Because if you don't know what to do, you're going to get lost and install things. You're going to do spiritual things. You don't want to be doing spiritual things. So, like I said, it's the 2023-12 version. There it is. If you go back to Eve, there's the version. So I'm gonna go here and click that. Make sure you install Java first, the JDK. Before you install Eclipse, install the JDK. And then I'm gonna go here and then there's okay, so be very careful. I didn't notice, but yeah, be very careful. Yeah, this website, it'll chow you if you don't know what you're doing. You see, this part it's talking about the latest one, 2024. Like I said, we're not looking for 2024. You're gonna scroll down here, 2023 12. There's the part that we want. Remember what I talked about? There's different versions of Java or editions. There's the enterprise edition. If you're for enterprise, this is for industries, right? If you're in the industry, you can install this one. If you're a C++ developer, you can install this one. If you're a community committer, committers, remember it's a Eclipse, it's a free open source IDE, right? That means multiple developers are contributing. It's not like a paid, you don't pay to download the Eclipse, it's free. So there's people who are contributing. So if you're one of the contributors, they suggest you install this one. And then this is for different, this is for PHP developers, embedded, it's for watches. If you're making apps for a watch, this is the IDE you should install. We don't want any of those advanced things. We want the very first one for Java developer because you're learning Java. If you're on Windows, like I said, you're gonna click here, this section. This for Windows, 64-bit systems. For macOS, you're gonna click here if it's Intel chip, ARM chip. And then here if it's NVIDIA, AMD, Intel, and then this part I think it should be ARM for the ARM chip. So I'm gonna click here since I'm on Linux, and then it's gonna take me to a different website, or it's gonna download. So for me, there it is. It's downloading, and then once it's done, you just for Windows, right? For Windows users, straightforward. You're gonna download the executable. I think it should be an executable. Let me just download. Let me see. Last time I checked, it was an executable. Um, okay, it's still okay. This is not. Yeah, I don't like this. This is not. This is not executable. So let me see. Let's click on this link. Mm, is it still zipped? Okay, sounds like it's showing zipped versions, only zipped versions. It's supposed to show you. Let me install the latest one. Let me see. Yeah, it's supposed to take you here. This I don't know why it's not taking me there. See, I think it's because I'm downloading older versions. I think that's why. If I was installing the latest version, it should have taken me there. So you see, when you click here, it allows you to see the executable, and then there's the executable. But the problem is you don't want the latest one. Like I said, it's gonna crash. So I suggest you just download the zipped file. I think this executable should be inside the zip file. Yeah, it should be. So just download that zip file. It's fine. The executable should be inside. Yeah, it should be inside. So once you download once it's finished downloading the zip file, you can unzip and then look for the executable and then double click and run. It should it should be straightforward. Yeah, it should be straightforward. Mm, okay, in my case, yeah, the Wi-Fi is I don't know. Every time when I try to download on the Eclipse website, it tends to be very slow when it's downloading. I don't know why. It just does that.
Oh, right.
Yeah.
I'm saying it's also slow on my side.
Yeah, I don't know what's Eclipse. What is Eclipse problem? I think this is you see this thing of free things. Free things are not always good. So if there's another AIDE called IntelliJ, which is
Mhm.
it's number one in the industry for Java and Kotlin. But the lecturers, universities, yeah, the universities tends to be outdated. They teach outdated things because they say yeah, we've had the systems since we started and they are robust or that it's always safe, but this is a good IDE IntelliJ, and there's a free version, the community version. This is for free, so I don't know why they don't make you guys install this one. It's straightforward to use this IDE. I personally use that for Java and Kotlin. Kotlin is like the child of Java. They saw the issues that was inside Java, then they made Kotlin. They improved Java to make a language called Kotlin. Because Java, it tends to have a lot of code. You're gonna see that how annoying that they how it is, how annoying it is. Java tends to have a lot of code. And according to the latest programming languages, they tend to have very small amounts of code. Java is just all over the place, but it's fine. While this thing is downloading, I'll leave it. So I just want to make a simple, show you a simple program inside Java. So there's a very important rule about Java, right? That you need to understand. You won't have to, okay, for the first few practicals, you have to worry about it. You are not allowed to use an IDE. For the first, I think, two practicals, you're not allowed. You're gonna use Notepad to write the code. I know
Mhm.
it's horrible, but you're gonna survive. So in Java, remember it's object-oriented programming. That means even the main function should be inside of a class. That's Java. So Java, when it was developed, they put in place that i- i- from the initial development of Java, they started putting object-oriented programming, unlike other languages like C++, whereby they only integrated after. So that's the difference between Java and other languages. It's purely object-oriented. That means everything, I mean everything needs to be inside of a class. So since everything needs to be inside of a class, this is how you can declare. Let me change the language to Java so that it can highlight Java. You can use VS Code. That's also fine. I would prefer use VS Code, but I'll just show you using Notepad++. So you're gonna say public class, right? Remember public meaning that it is public, it has public access. So that means the public has access to it, and it's a class. Remember, class is just a template or a plan for the actual to build the actual object. And when you name classes inside Java, they always start with the uppercase letter. So I'm gonna call this main class, right? And then you put curly braces like this. That's how you define a class inside Java. That's pretty much it. But then remember, each programming language needs to have a starting point. For example, when you go to the kitchen, where you're gonna put your pots? On the stove, right? That's the entry point, the stove. So with programming languages, it's sort of like the same thing. There needs to be a starting point. So when you compile, when you translate or compile the code, or you pass the source code inside a compiler, the compiler is going to go straight. It's going to look for a main function. If the main function does not exist, an error is going to occur. That's the only way any program can be run inside. Any program can be run inside any programming language. You need a main function. So this it's always going to be the same syntax, right? The only difference is going to be the name of the class, which is main. You might call it hello world if you want to. That's up to you. But I'm going to call it main. But then everything else remains the same. So public static void main, and then you're going to pass in an array of arguments for command line arguments. You don't have to use them, but this is the syntax. Even if you are not using them, you have to declare them like that. Every Java file, every Java project needs to have this, a main class, which has a main function. And then to output or send output, right, to the to send information to the standard output, you're going to say system dot out. System is a class. Remember what I said, classes start with an uppercase letter. So system, since it starts in uppercase letter, it has to be a class. Within this class, we also have an object called out. And then within that object or that class, there's a function called print ln or print line. This prints the text, but it also puts in an end of line character. So the cursor moves to the next line. And then hello world, our very first program. But remember, you need to put in a semicolon, just like in C++, to, it's sort of like a full stop in a way. So you need that semicolon to denote that this is the end of this statement or this sentence. And then we can just also put in comments. If you're coming from C++, comments are exactly the same. So I'm gonna say it prints hello world to the standard output, std out.
No
So
longer,
yeah,
I'm saying, so we no longer use the out.
yeah, it's no longer C out, because remember, each language is its own philosophy. So inside, okay, you can picture it in this way. Inside Java, right? You remember in C++ you said C out. Inside Java, you'd have to say system dot out.
Out.
Then call the function that prints
Mm.
text. It can be print, just like print with no, it doesn't append a new line, or you can use print line. It's up to you. And then there's also cin. It's actually very similar. System dot in. That's pretty much the that's pretty much the transition from C++ to Java. But then you realize that this will, it would actually not be like this. You'll see later. So it'll be, we'll pass it in another class called scanner. Just like a scanner, when you're at the till to scan, we need to pass it inside a scanner so that we can scan what's in the input stream. Basically, what's on the terminal. We need to use a scanner for that to scan. Just like that scanner that scans the what are they called? The QR codes when you're purchasing something at like Woolworths or Pick and Pay. So this is the equivalent to that in Java. And then this is how you write hello world. So now you need to save the file. So the trick here, right? Java is very, very, very specific. The name you've used for your class is how you're gonna save your Java file. If it's main starting with an uppercase letter, you need to call your file main.java. That's how it works. You failure to do that, crash. So you need to understand that very well, because the first few practicals, you're not allowed to use an IDE. You're going to type exactly what I'm doing here. So you're going to have a lot of mistakes if you don't understand the philosophy behind Java. So it's a must. So let's just try it out. Let me show you what I mean, that it's very picky. So I'm going to type main. As you can see here, it's main in small letters. We're going to have issues, but I'm doing that on purpose so that you can understand. So I'm gonna go to my okay. Okay, let me go here. Okay. Don't worry about this. It's an operating system thing. I have to locate it, so it's really demanding. So there it is, right? Main.java, and I've saved it under downloads folder. So now how do we run the program? You're gonna use the terminal. Even on Windows, you're supposed to use the terminal. For the first few weeks, you're gonna use the terminal for running your project. So what I'm gonna do, right? I'm gonna type ls to see everything that's inside of my file. On Windows, you type dir to list everything within that directory or folder. Directory is another term for folder. So via the terminal, you can type directory or dir in short to list everything that's there within that specific directory. So on Linux, you type ls, which is an abbreviation for list. So list, and then there's everything. So I'm looking for main.java, right? So how do I compile? It's simple. You just run. So let me expand the terminal a bit. So you just run Java C. Java C, that C stands for compiler. So I'm calling the Java compiler. So I just say Java C, followed by the name of the file that I'm going to compile, which is main.java. I should get an error, and you see the error. So I ran, okay, why is it saying Java command not found? Similar command. I don't know why it's doing this. Let me check again, but I do have Java installed. I don't know why it's doing that, but you're gonna run Java C followed by your main.java file, and then it should generate an executable. In your case, oh no, not an executable, it's gonna be a .class file. Remember, it uses a Java virtual machine. I'm not understanding why it's doing this, but it's fine. Let's do this. Let me reinstall the JDK. I already have it downloaded. Let me go to the files. I don't know why it's doing that. It's not picking up when I type Java, it's like the command doesn't exist. I don't know why it's saying the command does not exist. So I'm gonna double click and then open. I don't know why is it saying it doesn't exist. I do have Java JDK. It's fine. I'll install it again. Then I'm gonna type in my password to authenticate. Potentially unsafe. Something went wrong. Yeah, I think it's refusing because it's already installed. But yeah, I'm gonna try and fix that. I don't know why it's doing that. Yeah, it's an operating system issue. But when you run Java C, that's how you run the compiler. Oh, so Java C is not even picked up, but it's picking up Java. That's weird. That means the JDK is not installed in full, but it's fine. So let me try something here. So sudo dnf install JDK. Let me see if it's gonna install via the terminal. So let's wait and see. Does not have a compatible architecture. Didn't I download the right version? I think I did. You can try to add command line skip, broken to skip, uninstallable packages. Yeah, it's an operating system issue, or maybe I downloaded the wrong file. Oh, yeah, I see. You see, the problem, I downloaded an ARM 64. I don't have an ARM processor. Yeah, you see how important it is not to make those mistakes. I'm downloading something that's related to ARM, and I don't have an ARM processor. I have an Intel chip. You need to be very, very careful with these things. As you can see, I also made a mistake, but I think it was the mistake happened because I was caught up in talking. So I'm gonna delete this. So I'm gonna delete and the NPP. Yeah, I was wondering why it's refusing to install. It shouldn't refuse to install. So there's let's try to install it again. I think now it should work. So there is JDK 21, and then I'm gonna put in my password. So let's see now. Yeah, so now it's working, right? Because now it's not crashing. But yeah, you see, if you install the wrong things, you're gonna have problems. So there it is. To finish installing. Okay, I think it should be done. Yeah. So that's done. So let me go back to my terminal and then close the terminal and then open the terminal again. Okay, so let me expand the terminal. So I'm gonna say cd to change the directory and move into my downloads folder. And then there's main.java. So I'm gonna say java c main.java. Okay, finally now it's working. So as you can see, main.java, right? It says error, class main is public, should be declared inside. It's telling you that the class that you've created called main, it be declared inside of a file that's named main with an uppercase letter. It's not always direct, but I can sort of like infer what it's trying to say. So as you can see, Java is very, very picky. So I'm gonna say, are you sure you want to save or so? Okay, let me do this. Let me go back to the folder, and then I'm gonna go back here because it's gonna take me time to rename using other ways. So I'm gonna rename it and change the first letter to an uppercase letter, and then press enter. And I'm gonna close, and then I think I can close this now, and then go back to the terminal, clear the terminal, and then list again. So as you can see now, it's main starting with an uppercase letter M. Then I'm gonna run the Java compiler to translate that source code, which is written in Java, to the machine's native language, which is ones and zeros. Then I'm gonna press enter. This is gonna generate a .class file, right? So I can use ls to check everything that's there. As you can see, there's the .class file. Then I run the class file by typing Java followed by the .class file without the extension. Don't include the extension. Just say Java main, and then it's gonna know, oh, you mean the main.class. It automatically appends the .class. So if you say .class like this, it's gonna add another .class here, and then it's not gonna find the file. So therefore, you just need to type put in the name excluding the extension. And then when I press enter, I should see hello world. So enter, there's hello world. And then this is your very first Java program. So that's pretty much all you have to do to run every time. So if you make a change, you have to compile it again and say Java C, recompile, and then rerun, and then you see the changes. So that's pretty much all you have to know about Java. I know it's quite a lot of information to take in, but yeah, it's gonna be worth it. Java is it's not too bad. So let me save these notes. Yeah, this thing of using wine. I have to always locate the folder. So I'm gonna save it on downloads, normal text. Okay. So let me stop recording. Then stop recording. So do you
Thanks,
have
Louis.
any questions?